Greetings to you, all my viewers, and welcome to GeoNodes Challenge Series, where we dig deeper into what the Geometry Nodes has to offer. Also, welcome to the third part of this mini-series, Water Drops, and congratulations to make it so far. This series from beginning to start focused on how you can make particles stick to a surface and precisely control those movement of those particles. And I thought this water drop example was a very nice use case. I do hope you like this demo that you saw here. So that will entice you to follow this tutorial and recreate this, giving you a proper motivation to improve your art. Before we start, I want to give a big thank you to all of you that are supporting this channel. And to those of you that haven't subscribed or don't usually comment on the videos or like the videos, if you find the content valuable on this channel, you can help this channel a lot by doing this stuff: subscribing, commenting on the videos, pressing the like button, and of course you can also purchase the project files from Gumroad. So the main thing for me right now would be if you would post your opinions about the way I present stuff, because I really am trying to improve my teaching skills so you can benefit more from these videos. So until now we got to this point. We have this awesome animation of water drops coming on the mesh. I show you how you can expose different parameters here. I do this usually at the end of each video, so stay tuned for that if you want to see how to expose parameters. And we also added this pedestal that is modeled in the geometry nodes. And today we will be focusing on going deeper, and we will make sure that these water drops align nicely to the surface. We will also add more details. We will get that nice organic movement that the drops from the video have. That makes more believable the idea that these drops are actually following the surface. We will do a bunch of sculpting on this one, doing not a 0-1 Boolean mask, but an organic mask that has a fall off for this pedestal to give it a more interesting shape, and also to learn how can you do this kind of masks when you sculpt. We will do the part where we will send the data to the material, so we can use the position of the droplets in the material to do a bunch of cool stuff with the material, like making it look wet where the water drops have been. And we will also do the really cool part. This as you can see, the camera is basically following one drop. If you look here, you can see it. Yep, the camera is following the water drop. So we will do a geometry node setup that will parent the camera to a drop of your choosing, water drop of your choosing. So a bunch of interesting stuff. So let's start doing all of this. I'll do it a little bit out of order. First of all, I want to do this alignment to get rid of this problem, these water drops that are not looking quite right. And for that, we have to go to the water drop module somewhere here. And we want to do something with these instances. So I'm going to do a rotate instances because they obviously need to be rotated. So let's see which way. Let's take this align to Euler vector and plug it into the rotation. and let's see how we can align it. Well, we want to make these drops rotate to align with the surface, and we have to have a vector here that will do just that. And the perfect vector for that would be the normal of the faces of our monkey mesh. So we have this monkey mesh here. Let's do a quickly name so we can find it easily. And let's transfer an attribute from this one. Let's do attribute, transfer attribute, take the monkey mesh from here, and we want to transfer the normal, that is a vector. So let's take that normal, plug it into this attribute, and you can leave it to near face interpolate. This is just fine. It's just fine. Let's plug this one into the vector and see what happens. We see something happening, but if we mute this node, we see we don't actually have the right axis selected, because now we are rotating around the x-axis, but we actually want to rotate. If we look at this, we kind of want to rotate around another axis. No problem if you don't know which one. You can simply just try them all. There are only 3, so not much work there. So here you go. If you rotate around the z-axis, in this case, you fix your problem with the rotation. Awesome. Now let's do that organic movement deformation. We did some sculpting on the drops, but we treat them as an object. We did that here. We played with the initial object, this one, that it's the base of our water drops. So that means that all our water drops share the same transformation. If we kind of play with these values here, something like this, we see all the meshes get that deformation. We could play like with any object with the rotation, as you saw. We can play with the translation, or you can play with the scale and all that good stuff. And we did that playing with the scale here to give them different scales, as you can see. But we are basically altering just the container that has this geometry. If we want to modify this geometry individually, we have to turn these instances, meaning 6 duplicates in this case of the same geometry, into a real geometry. And we have this node called realize instances. And if we look at the output, now we have vertices, and lots of them. So right now with this, we have access to each point of each of the drops on this one, on this one, on this one. So we can kind of have access to all of them, and we can modify them. So what node would you use to alter geometry? The vertices. Well, we have this geometry set position node that gives us access to each and every vertex on this mesh. And we can do a very nice deformation by using a noise texture. So let's take a noise texture. And the thing that we want to do is to deform this surface. But we don't want to deform the bottom. We just want to deform the surface to give the impression that the water is basically, I don't know, wiggling, something like that. So basically we want to associate the deformation with the normal of the faces of these drops. So let's do just that. Let's first of all take this node and add a subtract, because like I told you in the previous video, this noise texture will move the mesh by 0.5. So if we subtract this, we get our thing back. And given the fact that we basically want to deform on this axis, on this axis using the normal, but we don't want to deform on this axis, Let's compose a vector. Let's do combine x, y, z and take the x and the y, and the z we can leave it alone. And let's see what happens if we plug it into the offset here. We get this huge deformation. So this is not exactly what we want. So let's do a vector math, switch this one to scale, and do something like a very small deformation. Maybe something like this, and check out the effect. If we mute this node, we get a little bit of deformation, making the drops seem to be like alive or something. But we said that we want to make sure that we do this deformation along the normals. So let's take this node and switch it to multiply and bring in the normal of these drops and plug it here. So now we get this deformation along the normals. Awesome. So this is what we wanted. Now, of course, we can play a little bit with the parameter of this node, like, I don't know, make this like 10. We don't really need all these details. We can even switch to 2D because we don't need to calculate on 3-axis. 2 is just fine. And as you can see, we get this deformation. So where is the organic movement coming from? Let me play a little bit in these settings. Yeah, something like this. It's looking nice. Check out what happens when we move the drops. See how they deform differently with each frame? This is coming from the base of this. So let's say I'm taking an input position and we plug it here. Nothing happens because this is the default of this node. But if we take like a vector math, and we start to play with the values, we kind of play with the deformation because we are modifying the coordinates. So simply by not plugging anything, we are using the position of these drops. So if the position changes by the drops moving down, so is the deformation. And that gives that effect of the water drops following the surface. They deform as they move, make them feel more alive. So this is it for this part. We managed to do that organic movement of the drops. We align them to the surface. So it's time to move to doing some things on this pedestal. So that's gonna be also a lot of fun. And let's think what we want to do. We kind of want to get a shape like this, where the mesh is higher in the back but lower in the front. And we want to keep the bottom straight. So we'll have to do a mask selection to make sure that we only affect part of the top mesh. And we want to make this deformation, like I said, based on the positioning. So going to our pedestal here, we already did these details here. So let's add another set position here. And let's first select the top part of this mesh. So I'm gonna do temporarily something like this. We see what's going on. And let's take the input position. And I'm gonna separate this because we care about only the height, the z-axis. So separate x, y, z. Plug this one here. Okay, excellent. And now let's do a compare. Take the z value and plug this one here. So what happened? We took the position of every point of this mesh and we compare it if it's greater than 0, because as you can see, if we align this nicely, the mesh has the origin at 0 and we have half of it down below 0 and half of it above. So by comparing to 0, anything greater than 0 will be 1, meaning will be part of our mask. So only this part of our mesh will get deformed, as you can see here. That makes sure that the bottom stays untouched. So we can cancel this value because we will do a special deformation. We have a selection for Boolean, meaning a point is either selected or not. So the idea is, how can we make a gradual change like that in the geometry? How can we make a mask that has a fall off, basically? This is the cool part that we want to do. Well, let's think. We want to modify the height value based on the position on the y value here. So we want to modify the z value based on information from the y value. So we have to do something with this y value. Let's take an utilities map range node. Let's plug the y value here. And now let's compose a vector that will only affect this z value here. So let's do a vector, combine xyz, plug this one to offset, and plug the result from here into the y. We can do a control, to the z. We can do now a control H. We don't need the other sockets. And as you can see, we already have something happening here. We can control the starting and the ending of the effect using the inputs, and this will be basically the strength of the effect. So this is how you can do that. You can also change this to something like more dynamic, and you can control where it starts, where it ends, and you can get really cool effects of that. And of course, if you want to make sure that your mesh or your setup stays procedural, you can look at the pedestal, and we have these values for the input and output. And I usually do this in the last part, but let's do it now because I want to show you how to do this. Okay, let's take a value, plug this value here, Shift D, plug this value here, Shift D, plug this value here, move this node a little bit down, and let's put 6 here, 4 here, and 1 here, copying the value from this node basically. And now nothing changes, but we have our access now to the values from the y, the x, and the z. And because we are using this y value from here, let's take this value and plug it here. And we can do now a procedural setup. So we can fine-tune these values, and no matter how you change these values, they will stay okay here. We won't need to readjust them in the map range. That's the idea. So let's do a math node, plug this one here, and let's say we do a divide. And let's start, our mesh is basically right now 4 meters, so it will have 2 meters on the minus side of the x of the y-axis and 2 meters on the positive side of the y-axis. So to access the minimum values from that side, let's do something like -4 divide. And what that did, took this value of 4 in this case and divide it by 4 and invert it, make it negative. So in that case, we will get a -1. So the minimum value will be somewhere here, and we can do something similar to get the maximum value. We can take this one, and we can do also a divide and plug it to the max. And if we do like a divide by 2, we will get a maximum that will be 2, meaning this. So no matter how we change this value, basically by taking half of the mesh, we will put the influence all the way to the end. And no matter what value we have here, by dividing by -4, we basically put the influence to almost to the end, -1/4 from the minimum. So now we have a procedural setup, so we can play with this value any way we want, and our deformation will still work just fine. Of course, you can play with these values and you can restrict the range of the effect any way you want. And don't forget, you have this output that will basically control the maximum effect. So now when we are at the maximum range here, meaning this way here, we will get the maximum push up, and when we are here, we will get the minimum push. Of course, you can play with these values and you can invert them and have quite the opposite effect, like this. So this is how you can get a gradual change, gradual mask fall off, even though the input of the set position nodes is just a Boolean. Cool, huh? I think so. Like I said, we can play with these values, but for this effect, given that this is supposed to be a rock, a more linear fall off, I think looks better. So I'm gonna leave it like this. It's good enough, and I think kind of got the point across, hopefully. Let me know in the comments. And it's time to move to doing this cool stuff. Let's do the data sending to the material shader. Because I plan to share the shader between the water drops and the droplets, I want to build a selector so I can do different things in the material for the droplets as to material. And I also want to send to the material the information about the position of the droplets here, so we can build in the material a mask that will let us make the material look wet where the droplets are and less wet here where the droplets are not. So how can we do that? Well, let's find the droplets module, and that will be here. Right now the output of this one is instances, and you can't pass this kind of information to the shader using instances, so we kind of have to make this real geometry. So let's do realize instances. We'll do a frame, so we know what this is all about. And what exactly do we want to do? Let's build first the droplet selector, and for that we will be using a capture attribute, so it will be stored on the geometry, this information. And we want a simple boolean, and we want this value to be on, and this can be on the point domain. It's okay, we can just plug this one all the way to the output, press the end panel, go here. This is important. Tooltip, whatever the name here, doesn't really matter. But what is important is to have a name here. So let's do droplets cell. So even better is droplet. Okay, this is very, very important because this is basically the field that we will access in the material to get the name of this attribute. You can leave this one anywhere you want. Yes, let's put. This is just for us humans to see and understand what's going on, like the tooltip, something like that. gonna give us a description and a name, but what Blender will look for is this field. So this is very important to fill it out. Excellent. So now we have a selector for the droplets. Let's duplicate this capture attribute, plug it here, and do a float this time. And what exactly we want to capture? We want to capture the distance from this the faces of these points and our mesh. So to the monkey basically. So let's do geometry proximity. What exactly we want? We want the faces of these droplets, and we want to plug this distance here, and we are basically wanting to capture this attribute not on the droplets geometry. Let me take this one here, but on the monkey geometry. So this is our monkey here. So we basically want to do something like this. Plug this one here and plug this one here. Excellent. And now we can simply delete these nodes. Awesome. So now we are looking at the geometry of the droplets and their faces. We check how close they are to the mesh, and we output this value as a float. And this value we will expose it here. And we have to do the same thing here. This attribute, let's say droplet dist. So, or path, or whatever you want, doesn't really matter. You can give it a name that may have meaning to you. So this is how we expose these values. And then if you go to, let me save, if we go to the shading tab, and we have this material of the monkey, we can do an input attribute and look at these values and say control droplet dist, do control copy, control V here. And if we look at this factor here, we plug it here, we get this gradient, as you can see here, that we can of course play with using a color ramp. So you kind of get something like this. You can use an ease and do a whole bunch of stuff. So as you can see now, if we play with the timeline that I don't have here, so let's quickly bring a timeline here. Where are you? Timeline editor here. Excellent. So if we play with this timeline and we move a little bit back, something like this, you can see it's working really nicely. We transfer this information from the geometry node setup to the shader. Awesome. So now let's go back to the geometry nodes, and we finished with this part, and it's time to do the coolest of them all and do the simple camera controller. And what we want is to isolate one of these drops and to parent it to a camera, and this way we can make a camera follow this drop. So let's add the camera to our setup. Let's go close like this and do Control-Alt-0. That will do it for us. And let's see how we can output this information. We have the water drops here. So let me save this setup. And in order to parent this, we kind of have to change. We don't need all the geometry. We basically need just one vertex, one point. And an easy way to do that is to go to point, geometry. We have here mesh. We kind of have to go a little bit back where we have instances here and do an instance to points, and take these instances from here before realizing the geometry. We don't care about all these deformation on the mesh. We just need the location of the points. And once we have this, we can plug it on this join geometry node. And as you can see, we now have this this point here. Now, two things about this. First of all, we don't really want to see these points, not on this setup. So let's do a set radius and put the radius to be 0. They are still here, the points, but we can't see it in this setup. And the second thing, it's very important to make sure that you do this transformation that is moving the mesh, basically, after you add these points. Otherwise, things will not work properly, because you will get the transformation of the points before you move the mesh. And so the camera will not actually see what you want to see. Let me change this color because this is an important transform. Now we have these points here. If we look at all the geometry that it's outputted here, we see we have 6 clown points and curves and mesh and whatever. We care about these point clouds that we added here, so we can actually use it for our setup next. So for that, let's do Shift A, let's do a plane, go to edit mode, A and X, delete all the vertices, and this will be our, let's say, GN, geometry nodes, camera, track. Something like that. Doesn't really matter, you can do whatever you want. And let's add a geometry nodes modifier. And in order for this to work, let's bring our setup here, our mesh. Let me look at this. And if we plug it here, we will get basically our setup again. But we don't really need that setup. What we actually need is to go to geometry, separate components, and we only care about the point clouds. So if we do this, our monkey disappears, and let's do Control H. We don't care about the other outputs. We get 6 points and we see nothing, and that's because we altered the radius. If we put something bigger, and look at the geometry, meaning selecting this setup, we can see our points now. We can control the radius here. Awesome. Let's put it into solid. We have these points, and now we want to build a selector for these points. So let's do just that. Let's do a delete geometry, and then we will select them based on the index, because we kind of have a limited number of points. And let's say take a compare node and switch it to integer, take the index and say we want to delete all the points that are not equal to whatever index. So that's how we can select one of the points, whatever we want, something like that. So now in order for this to actually work, we have one clown point here. We need to do something else. We need to turn this point into a vertex. So let's do points to vertices. And now we have one vertex. And if we play with the frame range, we can see this point moving. And now we having a point, we can do camera, select the other one, and do Control P and choose vertex here. Control P, vertex, camera tracker. Not enough vertices for vertex parent. We see our first problem, even though the setup is correct. And if we select the camera and then the parent and we do Control P and we have vertex, it's not working, even though we have this vertex that it's outputted. So why is that? Let's try to debug it. Let's go to the original geometry, and now we have 0 vertices here. So if we do Control P and vertex, not enough vertices. So we don't have enough vertices in geometry. That tells us that this setup, even though it's outputting a vertex, is not seen by the camera. So how can we fix that? Let's do mesh. Let's go to this setup, go to tab. Let's add whatever plane, do M. Let's do at center. And now if we look at this, we have one vertex. So if we take the camera and we keep the tracker and we do Control P and do vertex, now it's working. But this vertex doesn't know about this entire setup here. So how can we inform this vertex of what's going on? Because if we do the other way around, we have a parent, the vertex is moving, but our geometry is staying still because this camera doesn't care about this point. It only cares about the point from the input. So what we need to do is to transfer the position information from this to this vertex. So basically, we don't even need to turn this to vertices. We just need to do a transfer attribute, take this geometry from here. We want to do a transfer based on the index, and we want to transfer a vector because the position is a vector. So let's take the position, let's plug this one here, and now we have as an output the position of this point, and having this position we can do geometry, set position, plug it here, take the output from here and plug it into the position here. And now we see things starting to work. As you can see, now our camera, if we go here and we do we select our camera, G, Y, Y, move it something like this and something like this, and we play with the frame range. We see now the camera, it's basically following our point here. Awesome. So we did this camera tracker. And of course, if we want, we can expose this value from here and put it here. Go and group, take this one and say point to track. Okay, and we want to have it from 0. And now if we look at here, we can simply select all the points. And in order to make sure that we see what's going on here, we can do a geometry, join geometry, and take this point, plug it here, and now we have this visualizer. It will not appear in the render, but we can see what's going on and where is the point that the camera is basically following. So we have this setup complete. Yay, awesome. we have this awesome setup. So as usual, now I'm gonna show you how you can output some of the parameters to make the setup smarter. If you don't want to watch that, that's okay. You can expose anything you want, any way you want. Thank you very much for making it so far and watching this. Don't forget, if you want to support this channel, you can do so by purchasing the project files from Gumroad, subscribing to the channel, liking the videos, commenting on them. All of these are welcome support ways that I hope you will decide to do. Anyway, if you want to see the last part, what it is all about, we will be talking about the materials. I'm going to show you how I made the procedural materials for this project. I'm going to talk a little bit about the lighting, about the cameras, and a very cool thing that I did. In the demo, you saw there were transition between cameras. I did that in the compositor. So I'm going to show you how you can make a cool preset, a fade in, fade out in the compositor. So stay tuned for that. And thank you for watching. And if you keep staying, I'm going to show you some more cool stuff in just a moment. So congratulations to making it to the end of the geometry node setup for this project. I'm gonna do an overview of the entire node setup so you can take screenshots and stuff like that. And we will see if it's something else that needs to be explained. So this is the main setup. And we have this module that it's responsible for selecting, like I showed in the first video, between the input geometry that you can take from outside or the geometry on which the geometry nodes setup resides. We have a switch that controls this, and we have this target cell or not output, and then you can play with this and change to different objects, and then again you can keep the shape by doing things like that. We have this crease and mesh smoothness exposed as well. Then we took this information, the bounding box information, to build this setup, the procedural setup for the lines that are on the mesh, to decide where they start, where they end. I explained that in details at the end of the first part. I'm just going to show it to you now. You can make a screenshot if you want. And then this is the second part of the lines. We did this mask. We turned that into a mesh, into a curve, so we can follow it with another geometry. Let me switch to the monkey. I like the monkey better. And let's remove this. We have the animation, how the thing that makes the water drops move. It's all here. And what makes the water drops stick to the surface is this module here. And then we did some cleanup to remove a point that was uniting on the curves and the origin. This is responsible for making the water drops move. This is the trim one, I think that is trimming the curve, and it's making the geometry basically work. So this is it for that. This red thing here, it's just passing this line with the transforms that are positioning the mesh, so we can have a visualizer for the tracks. And also we use those tracks to make the droplets, taking the information before and after trimming and comparing it. This is the after trimming, this is before trimming. We instance the points, and then after instancing the points, we deleted the ones that were not supposed to be there yet because the track was not ready. We did some sculpting on the droplets. We did some controls to the outside. Also, that was detailed in the previous videos. So I'm just going to show you the geometry here. and we made the droplet stick to the surface, despite the fact that we changed the scale and we did a bunch of other transforms in the back. And what we did in this part, as you remember, we transferred the attributes regarding if this is droplet or if this is water drop, and we also transferred the gradient to the material to allow us to reconstruct the wetness of the surface where the droplets are. We also did a part that I haven't showed you. This is synchronizing the pedestal with the hero object. So even if we make the pedestal higher or something like that, or smaller, the geometry that you instance will be stick to it, and this is I didn't show you. So we basically did this setup. We took the Z height of the pedestal, we subtracted 1 to get the starting default value, and then we divide it by 2 to get half of it, and we use that half to add it to whatever transform we did for the hero object, the monkey, or whatever you have. So we added that half height of the pedestal to that value. So no matter how much we play with this value, the height of the pedestal, it will always stick to whatever transform we did on the mesh here, something like here. So if we make it like this, they will always stay like that no matter what we do with the pedestal. And for the pedestal itself, we started with a cube, and we did the deformation of the surface, and then we did this soft selection here that allowed us to deform and get this shape here, the one that we see here. And we did a hard selection here to make sure that all the changes affect only the top half of the mesh. So I think this is it. This is all. I'm just gonna show you now the setup for the camera tracker. This one. It's very simple. We did it today. Just more naming and descriptions in the setups. I did this. If you get the project from the gumroad, you can have a better idea what's going on just by looking at the name of the frames and stuff like that. So that will be the end for this part. Thank you very much for watching, and I'm looking forward to see you in the last part, the fourth part, that will deal with, like I said, the materials, lighting, cameras, and stuff like that. So until then, have a nice day and happy blending.